Hi guys, welcome to another video. So today we're gonna be talking about strawberry, which is finally here. So today is gonna be a very interesting video. I'm gonna go through the blog post on OpenAI's blog, and I'm gonna go and give my thoughts on this. So since we don't know much about how strawberry or O1 works, we're gonna have to do some speculation. We're also gonna have to look into some papers which can give us a hint on how this works. Okay, so let's get started. So the blog post starts with learning to reason with LLMs. So let me just give a zoom here, guys, so we can see better. We are introducing OpenAI O1. So this is interesting because they are not using the GPT nomenclature no more. This is a hint that maybe they are not doing generative pre-training transformer, right? O1 might be a shift, a paradigm shift on how these models are trained. And this can be interesting because this model is beating a lot of benchmarks and it's giving a lot of gains. It's having a lot of gains in a bunch of benchmarks, which is pretty interesting. So a new large language model trained with reinforcement learning. So this is also interesting because it can be to predict a missing token or to predict the next part or the next part of a sentence. So that's called next token prediction. So this is doing next token prediction, but so this seems to be a next token prediction, but using reinforcement learning to make the predictions better. So and this performs complex reasoning. So they are using complex reasoning here. So O1 thinks before it answers. It can produce a long internal chain thought before responding to the user. So here there's a lot more hints. Okay, so O1 or strawberry is basically chain of thought, and we saw a couple of weeks ago. So there was a model called Reflection 70B, which was basically this, right? But we don't know if that model works in reality. I cannot test that model. It's 70 billion parameters, so it's pretty huge, but it might be doing something like strawberry at home, right? Okay, okay, let's see here. Here we got the information. OpenAI O1 ranks in the 89th percentile on competitive programming questions, code forces, places among the top 500 students in the US in a qualifier for the US Math Olympiad AIM, and exceeds human PhD level accuracy and benchmark of physics, biology, and chemistry problems, GPQA. While the work needed to make this new model as I need to use as current models is still ongoing, we are releasing an early version of this model, OpenAI O1 Preview, for immediate use in GPT and trusted API users. Okay, so saying here that this model is really good for math, physics, and code in biology and chemistry. So our large-scale reinforcement learning algorithm teaches the model how to think productively using its chain of thought in a highly data efficient training process. So they might have generated a synthetic data set and trained a standard GPT model on it. That might be the case. Or they did add a new loss function to update the model using reinforcement learning. It's hard to tell. Yeah, we don't know. We don't know that. So we have found that the performance of one consistently improves with more reinforcement learning, train time compute, and with more time spent thinking. Test time compute. The constraints on scaling this approach differ substantially from those of LLM pre-training, and we continue to investigate them. So this is still work in progress. So here we got these two graphs. So this one is new, okay? This one is not possible and how they are used now. This one is basically showing that the more compute training, the better the model gets. And this one is, and as you guys can see, this is a better scaling. The more the model spends time thinking or working or generating tokens, the better it gets. This model, it does not have a limited context window per se. It does have 128K context window, can be worked multiple times. So this model is capable of giving an answer and verifying if the answer is good enough. And if it's not, it's gonna try to produce a better answer. So basically, this model might have a scorer, have a way to score a answer, and it might be running inside a while loop. So while answer is not good enough, so it's gonna gonna try to generate again. So this is my impression on how this model works. So here we can see evolves against GPT-4o. So this is a huge leap in performance and accuracy. So GPT-4o in the competition math in 2024 had a 13% and previous one 56 and O1 83. So it's a astonishing 70% jump in accuracy, which I don't know if this is a sign that if this model got this good, the next iteration might be close to 100%. That might be the case. So yeah, we might be getting close to 100% in some of these benchmarks again, and these benchmarks need to get better and better. So we're gonna need new benchmarks pretty soon. So competition code, you guys can see it's absolutely obliterates GPT-4o in this one. So from 11% to 89. PHP level science questions. GPT-4o had a good result, 56%, and GPT-o1 preview and o1 78. And here, guys, is the human expert. The human expert has 69.7%, which is pretty good. You guys can see it's a huge jump, and in this graph we can see more clearly, which shows the o1 improvements. So in math, is like a 34% jump. Math Vista is a lot more like 10, MMMU like more 10, MMLU like 4%. So this benchmark and this benchmark, the model is almost 100%. So 90 in the 90s, the model should be pretty good. So here we got physics is 92, biology is still not good enough, and chemistry, I guess because biology and chemistry are not very exact science. They require a lot of word knowledge, and physics is pretty much just math. So if the model knows how to do math, it should be pretty good at physics. So yeah, we got exams for English, calculus. So yeah, pretty good in some of these exams. Okay, so this is pretty much the benchmarks, pretty good. There's still room for improvement. I guess they are gonna work on that. They're gonna try to scale this to get better results. Okay, so how does this model works? Okay, let's go into this part now. So here they go on how this model works, but they are not talking about all the way. Okay, they tell us that this is chain thought with reinforcement learning. So that's what we know so far. We're gonna have to wait until another paper from Google DeepMind or Meta AI comes out with something that is similar and showing that this improves their models, Llama or either Gemma or Gemini. So chain thought. So similar to how a human may think for a long time before responding to a difficult question, O1 uses a chain thought when attempting to solve a problem. Through reinforcement learning, O1 learns to hone its chain thought and refine the strategy it uses. So they might have a way in which the model scores how good an answer is. I do think that. So here we're gonna see coding. So this is how the model works currently. Okay, so let's see. This is how GPT-4o works. You have the prompt and the model starts answering. So this is the answer for this. And here's how GPT-4o works. So we got the prompt and we got the answer. And the answer here is straight up code, but the chain thought is here. Okay, so this is how the model thinks. You give this prompt, it will generate a chain thought, which is pretty much going into detail in the problem, trying to understand the problem, going to step, creating strategies, evaluating the approaches, and verifying and building more and more a detailed representation of the problem, trying to see if the answer is good enough. So this is how chain thought works on O1. Chain thought currently on some models, they are available open source, is simpler than this. It does not do this complex thing, and they are running a more complex workflow probably to get to this answer. And this is an inference. On training, we don't know how this works, but it's pretty interesting because you guys can see that the model got a lot better, right? The model is getting a lot better. Okay, so let's see here. We can see that OpenAI put a lot of videos showing this model in action. There's reasoning. I'm gonna watch this.
The first example I have is very simple. This just counting the letter R's in a word strawberry.
So
strawberry let's start with the traditional, like existing model GPT-4o.
Right?
So as you can see, the model fails on this. There are 3 R's, but the model...
this sometimes the model got right, and sometimes it doesn't get right. So yeah, sometimes you might test it and the model might answer correctly, and sometimes it doesn't.
Says there are only 2 R's. So why does this advanced model like GPT-4o makes such a simple mistake? That's because models like this are built to process the text, not with the characters or words. It's somewhere between, sometimes called a subword. So if we ask the question to a model a question that involves understanding the notion of characters and words, the model can really just make mistakes because it's not really built for that. So now let's go on to our new model and type in the same problem. This is an O1 preview, which is a reasoning model. So unlike the
So you guys can see that it's doing the chain thought.
GPT-4o, it starts thinking.
So there are 3 R's in the word strawberry. Okay, it's correct.
About this problem before outputting the answer. And now problem, having a reasoning built in can help.
So there's this GitHub repo, which has compiled a lot of information about strawberry. So we can see here basically how this model might work. So you guys can see there's 31 input, reasoning output, and the model will increase the amount of input. So it's going refining the answer more and more, and it does need to trim sometimes the output. OpenAI developers talking about this. Okay, so there's a bunch of papers. So there's some papers from OpenAI which might give a hint on how this works. There's this paper from May 2023, which is Let's Verify Step by Step. And one of the authors is Ilya Sutskever and John Lake, which both of them left OpenAI, right? Ilya left to found a new startup, SSI, and John Lake left to Anthropic. So there's here in the abstract hints on how this model or this new approach can improve the accuracy of models on math, which is pretty much how this model, O1 is pretty good at math, coding, and physics and biology. It's not so good at writing. Okay, and there's also this one, which is Prover Verifier, again from John Lake. So it's pretty much a model that can verify the output of a LLM. So it's pretty much trying to verify how good an output is. So putting those pieces together, so I think these 2 papers might be the hint that we are looking for to try to replicate this. I guess I think that there's also one from, so this is one from Google DeepMind. So it's pretty much saying that scaling test time, which is inference, more optimal than scaling parameters. So it might be the case that as you guys can see here, it outperforms a 14 times larger model. So if we go to this math, let's say for example 8b, 8 times 14. So yeah, so using this approach, Gemma is a 9 billion parameter times 14. So using this approach, Gemma 9b could be better than 14 billion parameters. So using this approach, it could be the Gemma 27b could be as good as Llama 3 405b. Okay, so this is some of the things that we might see in the future. We might see that it might not be that long until we got a 9 or 27 billion parameter from Google beating Llama 3 405 billion parameter model from Meta AI. Oh yeah, so this is pretty much some of the papers. I think this new approach is pretty good, especially for people who are looking into using smaller models, because I think people would not mind waiting 1 or 2 minutes to be able to get a better answer. And if this approach does scales better and text time compute, it would be interesting, right? It would be interesting because training is a thing that takes a huge amount of compute. And if we are able to train smaller models that can perform better at test time, is a good trade-off in my opinion. But that's pretty much the video, guys. If you guys find this video helpful, you guys can consider subscribing to see more videos. Pretty much the video, guys. Hope you guys enjoy, and see you guys in the next one. Peace out.